Far above the tree line, on Canada's Arctic coast, there's a stretch of road that reaches the edge of the Arctic Ocean. Here, the map labels are unfamiliar to many within and outside of Canada. Small yet resilient, these northern communities are where ice and snow are important parts of the culture, and sun can disappear for weeks. I'm traveling between two of them, Inuvik and Tuktoyaktuk in the Northwest Territories. You'd think the cold would be the challenge, but the most unsettling part isn't the temperature. It's the feeling that the ground itself is giving way beneath you. The road dips, the surface ripples, and ahead, the ocean is swallowing up a community trying not to slip away. So here's the question. What happens when a foundational part of the ground, permafrost, starts to thaw? Today we'll explore what permafrost is, how climate change is reshaping it, what that means for people, wildlife, and the land, and why one northern community is weighing the possibility of moving. Along the way, we'll meet the strange and beautiful hills called pingos, and end with what all of us can do. So permafrost is ground that stays at or below 0 degrees Celsius for at least 2 years in a row. It isn't just frozen dirt, it's a mix of soil, rock, organic material, and importantly, ice. Ice that can bind the ground like cement. On top of this is the active layer, the surface that thaws in the summer and refreezes in the winter. Beneath that, the permafrost can be meters to hundreds of meters thick, locked in cold for thousands of years. So why does this matter? Permafrost is a hidden foundation. It holds up roads, buildings, and pipelines. It shapes the landscape, controlling how water drains and where plants grow. It also stores an enormous amount of ancient carbon, remnants of plant and animals that froze before they could fully decompose. When permafrost thaws, that carbon can wake back up. So the Arctic is warming roughly 3 to 5 times faster than the global average. When sea ice shrinks, darker water absorbs more sunlight. Warmer oceans and land surfaces add heat to the air. That kickstarts feedbacks that accelerate warming. And as temperatures rise, the ice in permafrost melts. The structure that kept the ground solid weakens. In ice-rich soils, the land can suddenly sink, slump, and buckle, a process known as thermokarst. What used to be a firm platform becomes uneven, wet, and unstable. But thaw isn't just a local engineering problem. When formerly frozen organic matter warms, microbes start to get to work, releasing carbon dioxide in drier conditions and methane in waterlogged areas. And these greenhouse gases trap more heat, which leads to more thaw, a reinforcing feedback loop. The impacts scale down to daily life. Foundations crack, roads warp, shorelines erode, and the stability of drinking water sources and food storage is threatened. So the Inuvik to Tuktoyaktuk Highway is a lifeline, a permanent road to the Arctic coast. Driving it, you can feel where the ground is changing. There are soft spots where the base is settling, and there are sections that have clearly been rebuilt and reinforced. And that's because constructing anything in permafrost is a race against heat. Engineers use thick gravel layers to insulate the frozen ground, geotextiles to separate materials, and careful drainage to keep water from pooling and hastening thaw. But as warming accelerates, maintenance gets more frequent and more expensive. A road that once rode over solid frozen ground now spans patches of ice-rich soil that can give way. Out here in the Arctic, you can also meet something rare, pingos. A pingo is an ice-cored hill that forms when pressurized groundwater freezes and expands beneath the surface, pushing the ground upwards. They look like solitary rounded hills rising from flat tundra, but inside they're mostly ice. And near Tuktoyaktuk is one of the highest concentrations of pingos on Earth. Some of them are giants, like the Dbh&x pingo, around 49 meters tall and more than 300 meters across. And these features are stunning, but they're also sensitive. As the climate warms, the ice cores can start to degrade. The surface can slump, and a once solid dome can collapse into a crater-like depression. It's a quiet transformation with big implications for local water flow, habitats, and the shape of the land. So at the end of the highway, Tuktoyaktuk sits on the Arctic Ocean, on ice-rich permafrost. Historically, sea ice buffered the coast, dampening waves. With less sea ice, storms have more open water to build over, and stronger waves reach the shore. Combine that with thawing ground, and erosion speeds up. And people here are responding. A community member told me they've been reinforcing the shoreline with rock, shipped in at a great cost, trying to slow the bite of the sea. It's a pragmatic, determined effort, but even with these defenses, the long-term outlook is tough. Many expect parts of the community may have to relocate in the coming decades. And relocation isn't just logistics. It's also identity, culture, and home. Decisions about where children will grow up and where elders will be honored. It's planning for uncertainty while living with daily change. And this is what the front line of climate change looks like. A community doing everything it can to adapt, yet forced to consider moving because the ground beneath it is literally changing. So thaw reshapes more than roads in towns. When ground ice melts, water can pool in some places and drain from others. New wetlands form, old ones dry. That changes habitats for migratory birds that rely on specific breeding grounds. Thaw slumps can send sediment into rivers and coastal waters, affecting fish and the nearshore food webs that many people depend on. Routes that were once safe become unpredictable. Travel for harvesting and cultural practices gets harder. The land looks familiar, but behaves differently. And that uncertainty ripples through daily life. So northern communities are experiencing a level of warming and a scale of cost driven largely by emissions from elsewhere on the planet. What happens in the south is felt directly in the north. That reality gives us all some responsibility. We can reduce emissions by improving efficiency, electrifying homes and transport, shifting to clean energy, and protecting carbon-rich ecosystems like peatlands and forests. We can support adaptation by backing policies and funding that help northern communities strengthen infrastructure, plan relocations when needed, and center Indigenous leadership in decision about land and the future. And we can listen, learn from and amplify northern voices already navigating this change. The ground is moving and the earth is changing, but so can we. Our choices can slow the thaw and support the people whose lives are most directly shaped by it.